Kia ora Year 13. This is a quick video on how to differentiate exponential functions. So I'm basing this on Delta chapter 1503 in the new edition, although the examples are ones I've made up. And if you've got the old edition, I think it's Delta 7.2, but you'll need to check that. And the questions are exactly the same. So go have a look back at your notes from class or from the textbook and have a go at these four problems. The questions 2, 3 and 4 are all going to use the chain rule. Alright, so we're going to start with a very, very bad graph, which you'll be used to if you're in my class. So here's y equals e to the power of x. Now, e is a really special number in calculus. It's equal to 2.7 blah, 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 blah. And if you hit e on your calculator, if you go e to the power of 1, I think you'll have to do, you'll get the decimal approximation for it there. And the reason it's so special is because if I take a point on the curve, for example, if I take x equals 4, and I work out the slope of the tangent to the line at that point, it turns out that the slope is exactly the same as the value of the function. In other words, it's the only function for which dy by dx is equal to the function itself. And that makes it very, very useful for lots of real life situations. We'll see some of them later on this year, for example, for modelling situations with growth and lots of other things. But today we're just focused on the mechanics. So on the next couple of slides, I'm going to go through those four questions. Okay, so the first one was just y equals e to the power of x, and we've done that already. Dy by dx is equal to e to the power of x. Now the second question was y is equal to negative 4e to the 35x plus 2. Okay, so what I've got here is a simple chain rule problem. The outside function is e to the power of all of this. This is my inner function. So we'll do the chain rule on this, or use the chain rule on this. Dy by dx will equal negative 4 e to the power of that function times the derivative of that inner function, which is just going to be 35. So the answer here will be negative 140 e to the power of 35x plus 2. Alright, question 4 was question 3, y equals negative 4 over e to the power of 7x squared. So before we get going, let's rewrite that with a negative power. Negative 4 to the power of e to the negative 7x squared. So it's simple chain rule again. Dy by dx will equal negative 4 e to the power of the inner function. Right, and remember that's because the derivative of e to the x is just e to the x. And now we're going to differentiate the inner function here. So it's going to be times negative 14x. Putting that together, we get 56x e to the negative 7x squared. Right, and one last question for a new slide. Okay, so we've got y equals e to the power of 1 over x. Dy by dx equals, well, let's not go straight into it. First we'll rewrite y. Y equals e to the power of x to the negative 1. So, dy by dx will be e to the power of the inner function, leaving it like that for now, times the derivative with respect to x of this thing here. So it's going to be negative x to the negative 2, using my standard rule for differentiating a polynomial. Now we'll clean that up a bit, and we're going to get this e, oops, what have I done? Where's my pen? E to the 1 over x times negative 1 over x squared. Alright, now it's fine to leave it like that, but a nicer way to write it would be this. E, negative E to the 1 over x squared. There we go. Okay, so now that you've come to the end of this, if you found that video pretty easy, you should do a few to practice from the end of exercise 1503. And if you're still having to think about this, then you need to do some more examples from near the start of exercise 1503. Thanks for watching. I made this using a new version of the app that I use, so I'd really appreciate some feedback from people in my class on the sound quality and the legibility of the equations and stuff like that. Thanks very much.